Yes, okay. So, in the previous chapter, we have discussed physical quantities like displacement, velocity, acceleration, etc. in connection with one-dimensional motion. Okay, there we have considered one dimension. That means along x-axis or along y-axis or along z-axis only. But now we will advance our study and we will study about motion in a plane. All of you know what is plane. Planes are like represented with the help of two coordinates. Here we need x as well as y. Hmm. So, but the problem here is that the mathematics of these quantities you have studied, like in 2 and 3 dimension, they are not easy as we have discussed in one dimension. One dimension it was very easy because we have to consider only one direction. But here that is not the case. Here we have many directions involved in 2 as well as 3 dimension. So, in order to introduce the mathematical part, we will introduce a new mathematical concept called vectors. Already you know what is the physical meaning of vectors, but today we will learn the mathematical part of vectors. It's very important not only for this chapter, throughout the study in physics. You need vector and vector representation and resolution of vector, etc. Throughout, in every chapter, that vector will come. So you should have a thorough understanding of this mathematical formulation of vectors. Okay. So in this chapter, we will describe the fundamental operations and properties of vectors, and using this vector language, motion on a plane. So instead of studying motion on a plane with the help of vectors, we will study as two motions. Okay, it is a sum of two motions in one dimension. So you know that plane means there are two directions. One is here, another one is here. Okay, so here, for example, I take suppose here there is an ant and it is crawling and it is moving like this here. So we want to study this motion. So how can we study this motion? Now, if I want to locate this object, so here the object is here. How can I locate? I will fix my origin here and I will take a coordinate axis. And if I want the displacement or the position, I can express it in terms of x coordinate and y coordinate. X coordinate means you move, for example, 3 units towards the x-axis, so you will reach here. Then along the y-axis, you move 4 units, then you will reach that point. Then the coordinate of that point becomes 3, 4. See here, the position is expressed in terms of coordinates 3, 4. Now, suppose we want to explain this motion, that is, the object is moving from the origin to that point. That we will divide into two portions. Instead of studying it as a single motion, first we will see just now whatever we have seen. First we will see the motion along this direction. See here, now what it is, motion along one dimension, and you know that things, everything, and then we will resolve it. Okay, again, we will study, this is the first part. We will study the motion along x-axis, then we will study the motion along y-axis. Then we will combine the motion along x-axis and motion along y-axis, then you will get the motion along plane. So what I told, to study motion in a plane, we were discussing about so many vector quantities. In motion, there are so many vector quantities. So dealing with vector quantities in 2 dimension and 3 dimension are not easy because there are many directions involved. In order to overcome this limitation, we will introduce the concept of vectors. Okay, what are the properties and the operations, addition, subtraction, multiplication, etc. of vectors? What is the benefit of vectors? Vectors will divide this problem. That means actually we want to study motion in 2 dimension. Instead of that, what we are familiar with motion in 1 dimension. So with the help of vectors, we will divide the motion in a plane into two parts. Motion in along one direction and motion along other direction. And when you combine this one, we will get motion along 2 dimension. Similarly for the 3 dimension also. So that is the benefit of vectors. So let us see how can we simplify the problems in motion in a plane with the help of vectors. So for that, what you need, you should have a clear understanding of vectors. Okay. So first, you know that all the physical quantities we have already studied. all the physical quantities in physics are classified into scalars and vectors. And in a simple language, actually, we will change the definition afterwards. But for the time being, you can understand that scalars are physical quantities which are having magnitude only. And vectors, they are physical quantities which are having magnitude as well as direction. Let me take an example here. Suppose I'm telling that a girl walks 4 meters. Okay. So what is the magnitude here? Here magnitude is 4 meter. What about direction? There is no specification. She can walk in north direction, south, west, or northeast, northwest, any direction she can walk. It is irrespective of the direction. We are not bothered about the direction. We are saying that a girl walks 4 meter. In that case, this 4 meter, see here, what are involved? 4 is involved. That means a number. And meter, what is meter? It's a unit. So scalar quantities can be represented with the help of a magnitude or the number and the unit. That's all sufficient to express a scalar quantity. But what about in the second case? We are more specific. A girl walks 4 meters east. Now it's very easy. For example, I'm standing for at the center of our ground, school ground, and I'm telling that a boy has walked for 5 meters. Then you cannot understand in which direction he has walked, whether left, right, or any other direction. We can't know. But if I'm saying that a girl was 4 meters east by standing at the center or anywhere, my origin, I'm fixing there. Okay, then I'm saying 4 meters east. Then you can locate that girl. What you have to do? First, you have to find where is that east direction. And after that, you have to walk 4 meters. Then you will meet that girl. So this one is more specific. So here, what is the magnitude? Magnitude is 4 meter. Again, you see, both the magnitudes are equal. A number is there, a unit is there. But one more quantity, additional information is involved here. That is nothing but direction. Here, in this case, it is east. So there's a difference between vectors and scalars. Okay. So we have already seen so many quantities. Okay, Adit,
Yes, sir.
can you say some 2, 3 examples for scalars?
Distance,
Okay, distance,
the speed,
speed,
then
so many examples. Hmm? What is the time now?
the time,
Time
9:30.
30, right? It's not 9:30 east,
Yes.
right? Yes.
Okay, sir.
Time, temperature, volume, mass, pressure. So many examples are there. Okay. Swati,
Okay, sir.
Swati, Swati.
Yes, sir.
Examples for
Sir,
vector quantities.
velocity, displacement,
Which one you have to tell first? Displacement, then velocity. Okay. Then so many are there. Displacement,
acceleration,
velocity, and
acceleration, force,
acceleration, force,
gravity,
gravity, momentum. All this can be said
momentum.
an example for momentum. All these can be examples for vectors. Okay, I want to tell you one thing. In this case, I don't have the elaborate slides, so you should take the lecture notes. It is must. I'll give you 2 minutes. If you are not having the notebook, take it with you and write along with me, whatever I am doing. Okay, I forgot to tell you that. Lecture notes are compulsory. There will not be any special notes provided. Let's hope all are ready with the book and pen. Okay, write neatly, whatever. So now first we have started our chapter. So write the heading motion in a plane. Then we have started our discussion with the vectors and scalars. So we have seen the division of physical quantities. Any physical quantities we are dealing, that can be this and not zero. This is just for example. Okay. So magnitudes, write some examples. Whatever I told for both. You write 2, 3 examples. Hope it is okay for all. Okay. Now our study of interest here is vectors. Okay, so here see, maximum quantities related to motion that we are dealing is nothing but vectors: displacement, velocity, acceleration. And acceleration due to gravity, obviously it's a type of acceleration. And then force will come. Okay, all these quantities are vectors. And when you come to 12th class, you'll study electric field, magnetic field. Everything is vector. Okay, so whatever quantity, maximum you're studying vector only. So you should have very thorough understanding about vectors. Okay, so now this is the mathematical part you required. Today we will discuss this one only, and then using that we will explain physics. Okay, so as I told, what is vectors? Vectors are physical quantities which have magnitude and direction. And more precisely, we have to add one more thing. Okay, I will tell you now itself, but don't think too much over that. Current is having a direction, it is having a magnitude, but even then it is not a vector. Okay, so there are some exceptions. So we have to modify the definition that we will do at a later stage. Anyway, you are not going to deal with current in this year. Okay, so for this time being, you understand that vectors are those physical quantities which are having magnitude and direction. Okay, now can you tell some difference between scalars and vectors? Now itself I told scalars having magnitude, vectors having both magnitude and direction. Next, uh, how can we change a scalar? If you want to change a scalar, for example, 4 meter, if I want to change that one, I have only one option. I have to change the value. 4 should be changed to 5. But what is the case in case of vectors? How can I change a vector? 4 meter east. It can be changed in two ways. One, magnitude. 4 meter can be changed to 5 meter. Okay, so there is a change in vector. Similarly, east can be changed to west. If I change it to west, then obviously vector changes. So vectors can be changed in two ways. Either it can be changed in magnitude or it can be changed in direction. For example, if you take uniform circular motion that you will study later, okay, in this chapter only we will discuss. So here you can see that it is a uniform motion. That means this object is revolving with a velocity, for example, 4 meter per second. Okay, so this value is constant. But in this case, the velocity is continuously changing. Velocity is continuously changing because at this point the velocity is in this direction. At this point the velocity is in this direction. At this point the velocity is in this direction. We will discuss. See here, 4 is not changing, magnitude is not changing, but the direction is continuously changing. In that case, you cannot say that the velocity is constant. So what I told, vector can be changed in two ways because it has magnitude as well as direction. So in order to change a vector, either you can change the magnitude or you can change the direction. But in case of scalars, you are left only with magnitude. There are no other option to change a scalar. Okay. Now, regarding operations, scalars, suppose I am telling that I have walked 4 meter and then I have walked 2 meter. Then what is the total distance I have traveled? 4 plus 2, 6. Okay, but what about in case of vectors? I'm telling that first I have walked 4 meter to the east, so 4 meter. Then I have walked 2 meter to the north. What is my total displacement? You can see that the total displacement is not simply 4 plus 2. Okay, this already we have seen difference. Okay, so the total displacement is here, and in order to find that we need another law. So vectors cannot be added like just like constants. We need special laws for addition of vectors. Is my concept clear? In this case, if I ask what is the distance traveled, I can just add 4 plus 2 is equal to 6 meter. Very easy. Distance, scalar. But that is not the case of vector. If I am asking you what is my displacement, then I cannot say that 4 plus 2, 6 meter is my displacement. 6 meter is not my displacement. Okay, so vector addition is totally different from scalar addition. Not only addition, all the operations. Multiplication, we cannot simply multiply two vectors, or we cannot add, we cannot subtract, or there is no division. Okay, division for vectors are not defined. Only addition, subtraction, and then multiplication. Okay, so first, the main difference is that vectors cannot be added as normal scalars. There should be some different laws for vector addition. That also we will study today. So that is about the vector part. Now let's see how to represent a vector. For example, you might have seen in some textbook or in your physics textbook itself. If you turn the pages, you will see the notation. Okay, so there are two ways to represent a vector. For example, I am taking the case of force. Force is a vector. Okay, so how to say that that is a vector? How to write with, how to like represent that it is a vector? So if in normal case I can write just f, but I want to say that it is a vector also. So in physics, the vector quantities are can be or vector quantities can be represented in two ways. Either we will use bold letters or we will use letter and above that there will be an arrow. Let me change the ink. Okay, so there are two ways to represent a vector. Either you can write a bold letter or you can write f or any quantity. For example, a is your vector, write a and put an arrow above that. What does that mean? It is a vector quantity. Okay, but here there is a problem. So in textbook you may see that this representation bold, but in our practical case it is not possible, right? Because if you want to represent any vector acceleration, you have to write a, then you have to darken it like this, like this, like this. It won't look nice. So which representation we will use normally? This one. So it is very easy. A you write, then put an arrow. So this is the commonly used one. But in some textbook you may see this one, bold letters. So if any quantity is written in bold letters, that means it is a vector quantity. But what is the commonly adopted one? Write the quantity symbol and then put an arrow. For example, acceleration. If you want to write velocity, here velocity. Okay, momentum, how will you write? Small letter p. Okay, all these quantities can be written. So this is the representation of vector. Representation of vector is over. Now, what is the meaning of f? F and with a arrow? That means it is a vector. That means it has two parts. What is that? One, it has a magnitude, and another one, it has a direction. So here, if I, for example, if I want to say what is the only magnitude I am interested. For example, acceleration due to gravity. Most of the time, what you will say, acceleration due to gravity is 9.8 meter per second square. And we know that is always downwards, direction is downwards. But normally while solving the problem, what you will take, acceleration due to gravity is equal to 9.8 meter per second. Okay, so in that case, we are talking only about magnitude. How magnitude of a vector represented? So for that, there are two ways, because there are two ways of representation of vectors. If we are using bold letters for vectors, then magnitude can be represented as normal one. So we are using, so we will not follow this convention. Mainly we follow this convention. So if I write, this is the symbol of magnitude. You might have studied in maths. Okay, so for example, I told that acceleration. How to represent the magnitude of acceleration? Write the vector and then put two like brackets. Okay, so if you see this one, what does that mean? Acceleration. I'm telling that acceleration is equal to 9.8 meter per second square. Nothing wrong in that. What does that mean? The magnitude of the vector, acceleration vector, is 9.8. Okay, hope you are following. If you have any doubts, you can raise the on the mic and ask. Okay, don't hesitate. So we have studied how to represent a vector. There are two methods, bold and by a arrow. What is the normally used one? That is this one. How to represent the magnitude of that vector? F, you write the vector and put it inside the bracket. Then it becomes a magnitude. Okay, so that is about here. And how to graphically represent this diagram? So here to draw an arrow. Okay, so if you draw an arrow, so for this example, this is vector A. Okay, what does that mean? This portion is called, so that portion is called tail, and the other portion where the arrow is there, that is called head. Okay, so in order to diagrammatically represent a vector, what you have to do? You have to draw an arrow. While drawing the arrow, you should take care of two things. How magnitude will be represented? Here I am drawing two arrows. Okay, so this is vector A and this is vector B. Vector A and vector B. Okay, Harinandan. 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 What here? Pavan. Pavan.
Yes,
Is
sir.
there any difference between vector A and vector B, or both are same?
Both are same,
Both
sir.
are same, no difference.
No difference, sir.
Okay, anybody else? Anybody else? Okay, Pavan, tell me how many parts are there for a vector?
Two parts are tail and head.
That is for graphical representation. Vector contains two informations. What are they? One is its magnitude, another one is direction. Okay, so here you see vector A and vector B, whether they are in same direction.
Yes, sir.
Okay, so direction is same. Whether they have same magnitude.
No, sir.
So how did you understand that?
Sir, B is shorter than A.
Yes, shorter than A. So that means what? The length of that line represents the magnitude. Okay, so
Okay.
here in this case, both are having same magnitude, but they are, sorry, same direction, but different magnitude. So here vector A is not equal to vector B. Now I'm drawing another vector. Okay, what about now, Pavan? Vector A and vector C, whether they are equal?
No, sir.
What is the difference here?
They are
Magnitude is same.
op-
Okay?
opposite directions.
Direction is different. Okay,
Okay, sir.
understood? Yes.
Okay.
So there are two parts. One is tail, another one is head, and we will represent diagrammatically with the help of an arrow. So with that arrow, the length represents the magnitude, and arrow gives the direction. So this is the graphical representation we will use. Okay. So we have seen how to write it in letters and how to write the magnitude, how to diagrammatically represent it. Now let's move to the next part. Now we are going to see the different types of vectors. Okay, so first type of vector we have already discussed. I mean the concept. Okay, so let me say the first one, equal vectors. Okay, Rishikesh,
Sir,
can you tell me what will be equal vectors? If two vectors to be
Equal
equal, what
magnitude
under
and
should be
direction.
equal magnitude and
Ma-
same
Equal
direction.
direction.
Same direction. They should have same direction. For example, if I draw a vector like this, vector A, then how to draw an equal, same magnitude I have to take, same direction I have to take. In this case, what I can say? I can say that vector A is equal to vector B. So when we can say that two vectors are equal or equal vectors, two vectors are said to be equal vectors if they have the same magnitude and direction. If they have the same magnitude and direction. Okay. Now let's take another type, opposite vectors or negative vectors. Second type is opposite vectors or negative vectors. Aisha Lena,
Yes,
Aisha Lena.
yes, sir.
Can you say what will be opposite vector or negative of a vector?
Either the
What
either
about magnitude? What about direction? That you just tell.
direction and the opposite direction and the magnitude are opposite.
How magnitude can be opposite?
Either the direction will be on the one side and the magnitude will be on the other.
Magnitude will be other side. I didn't understand that. How can magnitude be on the other side? Magnitude has not having any direction. Magnitude means only that value. 4, 4. 4 is a value. Isn't it? Hmm? So here, here you see equal vectors. Equal is there. So what and all equal? Its magnitude is equal, direction is equal. Okay. Opposite means it is a term related to direction only. So in this case, negative vector or opposite, they will have same magnitude. Magnitude will be same, but the direction will be opposite. Direction will be opposite. Same magnitude, opposite direction. In that case, you will call it as opposite vector or negative vector. For example, I'm taking the same example. See here, vector A. Now, if I want to draw the opposite or negative of this vector, how to draw negative minus A? Very easy. Take the same magnitude, same length, and then reverse the direction. So this is nothing but minus A. This is the meaning of negative of a vector. Okay. Normally we will use negative vector. So A minus A minus A. What is the difference? They are having same direction, but sorry, same magnitude, but opposite direction. For example, if you take this is origin. Suppose from here I travel 4 meters. So I will say that I have traveled plus 4 meter. and in the reverse direction some other person travel 4 meters, so I will say that minus 4 meter. So see here, both of them having same magnitude, 4 meter. One is plus, another one is minus. What does that mean? Their directions are opposite. That's all. One is moving to the east, another one is moving to the west. So that is the meaning of negative of vector. From the term itself you will understand. Okay, next one, like vectors. Okay, Nishaj,
So,
can you just guess? It's not that easy, Like vectors. So first two cases, if you consider, then you will understand what will be like vectors. In equal
sir,
vectors, magnitude should be same, direction should be same. Opposite vectors, direction is opposite, but magnitude is same. So what will be like vectors?
so the vectors having equivalent magnitude and similar directions.
Then they are called as equal vectors. Same magnitude, same direction.
Uh,
I will tell you one example, then it will be easy. So this is vector some other vector P, and this is vector Q. I'm telling that these two vectors are like vectors. What is same in both?
so direction is
Direction
same.
is same. Okay. So if two vectors are having same direction, then we will say that they are like vectors. If both of them are equal, then also they are like vectors, but we will use more precisely the term equal vectors. Clear? So unlike vector, what it will be?
Uh,
Two vectors in opposite direction. For example, these two. Magnitude is irrelevant. We are just concerned about the direction. Okay. So equal, opposite. Okay. Next. This is the most important one, that is called unit vector. Okay. So we will see what is unit vector. First, we will see the definition of unit vector. For example, this is my vector. Okay. So vector A. This is my vector A. What is the direction of that vector? Along this one. Okay. How to represent the magnitude of this vector? There are two ways. I can represent just magnitude of vector A like this, or if I just simply write A, that means the magnitude. Okay. So unit vector is defined as unit. So what will be the unit means? Unit means its magnitude is unity. So what is the implication of this one? It gives the direction of a vector. Okay, it will say in which direction. I will say you what it is. Okay, so you should understand what it is. Unit vector, very very important. So in order to get a unit vector, for example, for unit vector A is represented as A cap. What does this mean? It is a unit vector along vector A cap. How can we get A cap? Take the vector A and divide it by its magnitude. So here, divide by magnitude. I told division of two vectors are not possible, but dividing a vector with a scalar, so magnitude, it's a number, that is possible. But you cannot divide vector A divided by vector B, is not possible. Here I am taking only the number, the magnitude, or for more precisely, I can write just this one. Okay, or we can write like this also. So what is unit vector? Unit vector is nothing but that is a vector. And what is specialty of that vector? Its quantity, its magnitude is always unity. Magnitude is unity. And then if the magnitude is unity, what is the need? It gives the direction. Direction. It gives the direction of the vector. What is the implication of this one? Let me say you one example. Suppose I have this coordinate system, and I'm telling that the this is x-axis. I'm telling that the unit vector along x-axis, the unit vector along, that means the direction along x-axis is represented by a unit vector I cap. So what is the meaning of I cap? I cap symbolizes that what it symbolizes. It gives the direction. That means the object is moving along x-axis. Okay, now suppose a car is moving from origin. The car is moving. If you are not following, just remind me, I will explain again. Okay, very important concept. Okay, so here car is moving, and I told that the car has moved 10 kilometer or 10 meter. Just example you take 10 meter. The car has moved 10 meter. So when I say that 10 meter, so this vector A, how to represent vector A, or how to say the unit vector? What is the definition of unit vector? So tell me, Ashwin,
Yes, sir.
in this case, how can we define unit vector? I cap is equal to. What is the definition for I cap or unit vector? Vector divided by magnitude, right?
Yes,
Okay, so vector I am writing A vector divided by, what is the magnitude?
sir. X.
What is that is given, the value is given,
Sir, 10
magnitude
meter.
10 meter. So A divided by 10. What is the implication of this one? See here, from here I can write vector A. What is vector A? Tell me, Ashwin, vector A is equal to, from this expression, vector A is
Sir,
equal,
um, I cap by 10.
that means 10 into I cap. Clear? So this is
Sir,
the meaning of what unit vector. See here. Now I will tell you. Okay, I will call someone. Okay, Soja Vaishnavi. Soja Vaishnavi.
Sir,
Okay. So now I am telling you that another vector is B is equal to 12 I cap. What is the meaning of this one? Can you tell me? 12 I cap. What and all information you can get from that? I am telling that I am representing a vector. Vector B is equal to 12 I cap. What is the implication of that, or what does that mean, or what information you can get from that notation? So there are two parts, 12 and I cap. What 12 represents?
the magnitude.
Magnitude. That means I have to move. I want to meet a person. Suppose I am standing here and I'm asking you the direction. Okay, so since you are very intelligent, you will not tell you the direct thing. So you will tell that. So you have, if you want to meet that person, then you have to walk 12 I cap. Then how can I decode that information? So first information is that I have to walk 12 meter. Okay, suppose it is meter, 12 meter. And what about I cap, Soja? What does that I cap represents?
Mm.
Vector has two parts. One part
Direction.
already you got, magnitude. I cap direction. Which direction? Which axis I have to walk? Hmm? I told I cap is the unit vector along x axis. Okay.
Okay.
Is there any network issue?
No.
Okay.
No,
So
sir.
can you 12 I cap? What does that mean? I have to walk 12 meter along
X-axis.
x-axis. That's it. That's it. Very good. Okay. So here that is the implication of unit vector. Unit vector gives the direction. So with this unit vector I cap, now I can make infinite number of vectors. I'm telling that I cap is the unit vector along x-axis. That means that is constant. The direction of x is represented with the help of I cap. What is I cap? Vector divided by magnitude. So if you know the magnitude, you can write any vector. If I am telling that 1000 meter is your magnitude and you have to walk along x-axis. How can I represent? Yes, directly you can write vector A is equal to 1000 is its magnitude and I have to walk along x-axis, then I cap. Because I cap is the unit vector along x-axis or it gives the direction. Now, similarly, I can take unit vector. I told along x-axis, the unit vector is normally represented by I cap. Y-axis, the unit vector is represented by J cap, and Z-axis, the unit vector is represented by K cap. These are the unit vector along I, J, K. Sorry, along x-axis, y-axis, z-axis. Okay. So now, Namida.
Yes,
Namida.
sir.
Okay. Now I am telling that I want to represent a point which is 3 meter from origin and it lies in the y-axis. How can I represent it vectorially? Once again, 3 meter along y-axis. How will I represent?
3j cap.
3j cap, that's all, very good. Okay, so here I have x-axis, I have y-axis. Now one more question, xy. So this point, here 0, 1, 2, 3, 4, 5. Here also 1, 2, 3, 4 I am taking. Suppose this is 3. This point. So I started walking from here and I reached here. See this? Now we are going to motion in a plane. I am walking like this. Okay, so I have reached here. I have reached here. Can you tell me what is my displacement, Namita?
Sir,
Vectorially,
3,
how can we represent vectorially?
3i cap plus 2j
First,
cap.
as I told earlier, it is a motion in a plane that we can divide into motion in two one dimension. One is along x-axis, another one is y-axis. So first, what I have to do, I have to walk along x-axis. How many distance? 3.
3i
So that can be written as 3i cap. Then plus
2j cap.
that's all. So from here we have to walk like this direction. So it will be 2j cap. See here 3i cap plus 2j cap. If I give this information, you can say that first along x-axis 3, along y-axis 2, or the point is nothing but 3 by 3 comma 2. So this point, my position is 3 comma 2 mathematically. Okay, or with a vector representation, I can write 3i cap plus 2j cap. Now again, I am telling that another person. Okay, Aman, 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 absent. Okay. You are there. Okay. Now I am telling that my position is 2i cap plus 4j cap. So can you locate me where I am standing now? How can I do? Are you there? Okay. Adviga, Adviga.
Yes, sir.
I'm telling that with respect to the origin O, my position is 2i cap plus 4j cap. Now your your aim is to find me where I am standing.
Sir, 2 along x-axis and
Okay,
4
so
along
I have to
y-axis.
walk 2 along x-axis and
4
along
along y-axis.
y. So where I will reach? I will reach here. Yes. Congratulations, you found me. So here 2 comma 4. You understood what is the implication of unit vectors? With the help of unit vector, you can represent any direction. So the most important thing about unit vector is that it gives the direction. It gives the direction. Okay, magnitude is irrelevant. Magnitude is just value. So value into unit vector, if you write, you will get that vector. For example, I write n cap is any unit vector. For example, vector A divided by magnitude of vector A. Then what I can write? I can write that vector A is equal to first you write its magnitude vector A multiply by n cap. So I can represent any vector with the help of its unit vector. Hope it's clear to everyone. So you can say that the unit vector of the given vector is a vector of unit magnitude and has the same direction as that of the given vector. So here you see, if I am telling that n cap is the unit vector along A, vector A, what does that mean? N cap, what is its magnitude? Magnitude is unity, 1. What is its direction? Direction is along the direction of A, vector A. So that is the meaning of unit vector. And what else we have seen? How to find the unit vector? Vector divided by magnitude. It gives the unit vector. Okay. Now, we have seen most important thing, that is a unit vector along x. Vectors along x, y, and z axis can be represented as I cap, j cap, and k cap. Okay. One more property is there. See here. So I'm drawing 3 axes like this, and this is x-axis, this is y-axis, this is z-axis. So here unit vector along, I will draw with another. Unit vector along x-axis is this one, that is I cap. Along y-axis is j cap. Along z-axis is k cap. They are unit vectors, and one more thing is there. They are mutually perpendicular to each other. See here, all of them are mutually perpendicular. I is perpendicular to J, J is perpendicular to K is perpendicular to I, J and K are perpendicular, J, F, all three vectors are perpendicular. Okay, so we have given a special name to these three vectors. They are called as orthogonal unit vectors. Orthogonal unit vectors. What is the meaning? Unit vectors already you know. Orthogonal means mutually perpendicular. So that is about unit vectors. Hope it is clear. Avantika, Avantika,
Yes, sir.
is the concept of unit vector clear?
Yes, sir.
Why we need unit vectors?
Sir, for the direction and magnitude.
To get the direction of any quantity. Okay, any vector. Good. So now next another type of vector. So here collinear vector. Can anyone guess what is collinear vector? Collinear vector. Anybody? Any guess? Okay, it is nothing but the vectors lying on the same line. I have a line here. So one vector I am drawing like this, another vector I am drawing like this. See here, all these vectors, vector P, vector Q, vector R, all these vectors are lying on the same line. That's why they are called as collinear vector. Okay, that's not that. Okay, parallel vectors. Okay, the term itself says two vectors are parallel. See here, these two vectors are parallel to each other. Next one, anti-parallel vectors. Anti-parallel vectors means they are in opposite direction. Okay, so that is also coplanar vector. What will be coplanar vector? Any idea? Coplanar vector. Give me some guess. Intelligent guesses are welcome. Coplanar. I told co-linear, lying on the same line. So coplanar will be vectors which are on the same plane. That's all. Any two vectors if they are in the same plane. If any vector I draw on this monitor, see here, any vector, they are lying on the same plane. So they are called as coplanar vectors. Okay. Now we are moving towards the multiplication of a vector by a real number. That means multiplication of two vectors. Multiplication of vector, there are two parts. One is multiplication of a vector multiplied by vector. And this also again divided into two. We'll say that scalar multiplication or dot product, and another one is cross product or vector multiplication. Okay, so vector into vector, that we will do it later. That is, there are two parts. We have to learn what is dot product. Another one you have to learn what is cross product. Here we are not bothered about that complication. Now we are going to multiply any constant lambda, and you are multiplying by a vector a cap. So let's see how to do this multiplication. That is multiplication of a vector by a real number. So if you want to multiply a vector by a real number or positive number, what do you have to do? You have to multiply the magnitude of that vector by that constant. For example, I'm telling you, give me Sudeshna. Sudeshna. Give me an
Sir,
example for vector in two dimension. Just now we have seen how to represent anyone. Any vector in two dimension. For example,
3j cap.
but 3j cap. That is only one direction is there. Y axis. I need two dimension, two direction.
3j cap plus 2i some.
First you say x axis. So 2
Okay.
I cap plus
I
3.
cap.
Okay. Now my value of lambda is 4. Value is 4. Okay. Now Abhinav. Abhinav.
Yes, sir.
Can you tell me what will be lambda into a cap? Lambda into a cap. What it will be? Here no need to worry. This is scalar quantity. It is having only the magnitude 4. So you have to deal only with the magnitude. Any idea, Abhinav? No problem. It's very new to you. I'm just asking if you can have any guess.
No.
No idea. Anybody else? See, you should be sure that you should know the basics. These are not basics. These are the new things you are learning. So thinking process is involved. So if you are unable to answer also, don't hesitate to answer.
8 I cap plus 12 J cap.
Yes, that's all. So what is that? There are two portions. Okay, 2 I cap and 3 J cap. So there are two magnitudes. One is 2, another one is 3. So in order to multiply this one, you have to multiply the first value. 4 into 2, magnitude into magnitude. That's all. So 8 I cap plus 4 into 3, 12 J cap. That's all. Clear? Clear? Is that
Yes,
clear?
sir.
Okay. Now tell me one example in physics where we are multiplying a vector with a scalar. Okay, before that, let me frame this question like this. So if you multiply a scalar with a vector, whether the product will be scalar or a vector. I am multiplying a scalar, a real number, 4, and I am multiplying it with a vector A. So what is the resultant I am getting? Is it a vector or a scalar?
Vector.
You will get a vector 8i plus 2, 12j. See, I is there, j is there. That means the information of direction is contained inside that. That means that is surely a vector. Okay. So what I asked, okay. Now from physics, can you give me one example where you are multiplying a scalar and a vector? Then you will get obviously a vector you will get. Anybody?
Force.
Force.
Displacement into time.
Displacement in, okay, two examples I will write both. Okay. So displacement into time. What is displacement into time? Displacement into time. Is there any quantity like that? Here displacement by time. So displacement divided by time. What you will get? Ashish. Ashish. Ashish K. Ashish K.
Sir,
Displacement by time.
sir, displacement time velocity.
Velocity. So from here I need multiplication. So this can I can write it as velocity into time is equal to what I will get displacement.
Yes,
So
sir.
here vector multiplied by scalar is equal to its displacement. Okay, another example, as someone told, force F is equal to mass into acceleration. Mass is a number, F is a vector, mass is a number, A is another vector. So F is equal to ma. So you understood. Hope the implications are clear to you, all of you. Okay. Now, so the first operation is over. What was the first operation? Vector multiplied by a real number. We are yet to discuss vector multiplied by vector. That's more complicated. We have two products. Okay, that we will discuss at later stage. Now the easy operation, that is vector multiplied by a real number we have taken. Next one is addition of vectors. Okay, here this portion also we can divide it into two parts. If the vectors are collinear, first case we'll take when two vectors are collinear. Okay, so here I will take two vectors, 2 I cap A. A is equal to 2 I cap. B is equal to 3 I cap. See here, B I have drawn longer one because its magnitude is more. So what I can say, vector C is equal to vector A plus vector B. See here, both are in same direction. Both are in same direction. So what I can say, vector A plus vector B. It is simply saying that, let me take the example. This is origin, and first I am walking 2 meter along x-axis, and then I am walking 3 meter along x-axis. So what will be the total distance traveled? Shruti VS? Shruti VS. What will be the total distance? Displacement. Total displacement.
2 plus 3.
Displacement. Total displacement. Displacement is a vector. You told about magnitude. What about direction?
5 I cap.
Good. That's also total distance is 5 I cap. So it is equivalent to saying that I have traveled 5 along I. 5 I cap. So here, if the vectors are collinear, then my part is very simple. So that means I have to just add them, just add the magnitudes. That means when vector A and vector B are two vectors acting in the same direction. How to get the resultant vector? We'll say the resultant vector. Okay, resultant means total vector. The resultant vector is obtained by adding the magnitude of A and magnitude of B. What about the direction? Direction will be same as A and B because A and B are having same direction. So you have to add the magnitudes 2 plus 3, 5. And then same direction, I cap. Very easy when they are collinear. But now let's take a case when they are not collinear or when they make some angle. Okay, so I'm taking two vectors here. One is here, this is vector P. Any letter you can use. Normally we will use capital letters. Okay, vector P. So this is vector P. Another I am taking vector Q or A, B only take. So it will be general term. Anywhere, anytime we'll take this one only. Vector A and this is vector B. So this is what is the length OA. This is the length is OB. Now, if I want to see here, they are not collinear. They are coplanar, not collinear. If they were collinear, it was easy. Just add the magnitudes, gives the same direction. But here you see the direction of A is almost along what I can say along x-axis. But what about B? It is along like so. This is along east. So here you know in map this is north. Okay, so east, west, south. So if you see A is along east direction, B is along almost northeast direction. So their directions are equal, not same. They are making some angle between them. If they make some angle, obviously they are not collinear. If they are collinear, the process was very easy. Just add the magnitude, same direction. But in this case, it is not. Now, for adding these vectors, this type of vectors, which are making some angle with each other, or when two vectors are inclined at an angle. See here, you can see that there is an angle. If I draw the vector here, A, there is an angle between them. Okay, so if two vectors are inclined by some angle, then what I can do? I have to use two laws. Any one I can use. Whichever is easy for you, that you can use. First one is called triangular law of vector addition. Another one is called parallelogram law of vector addition. Both will give you the same resultant. So it is irrespective. Which one you feel easy, that you can apply. So let me say what is triangular law of vector addition. What is my A? I want to add vector A and vector B. Then I have seen whether they are collinear. No, they are not collinear. If they are not collinear, how can I add them? I have to apply triangular law. How can I apply triangular law? Let us see. For that, what you have to do? See here, if I there is that I can shift vector along this plane at any point. That does not change the direction or magnitude. For example, I can draw vector A like this. Okay, suppose this is 5 centimeter long and direction is along x-axis. Now, if I shift the vector here, again this is 5 centimeter, direction is along x-axis. Still, it is A. So the relative position, relative placement of vector is irrelevant. That is depending on if you draw in your notebook, it will be different. Okay, but the concept is same. They are having same direction and same magnitude. Similarly, B is here. I can take this B and I can place it anywhere on this plane. It will not change this. For example, I can draw the vector B also here. What is the thing I have to take care of? I have to take care of the length. Length should be same, and see the direction. Direction is again northeast. Okay, I cannot draw it like this. Then magnitude is same, but the direction has changed. That is not possible. So I can shift the vector without changing its magnitude and direction anywhere along this plane. So if I move these vectors, vector A or vector B, if I move, that doesn't change the vector until I change the magnitude or the direction. So using that property, it is nothing but the frame of reference from where I am seeing. I can take any frame of reference. The vector remains same, magnitude and direction. Okay. So now what I am doing, in order to add these two vectors, I am moving vector B in such a way that the tail of vector B is meeting the head of vector A. So where is the head of vector A? This is the head of vector A. This is the tail of vector B. Now I'm shifting the vector. I told the shifting vector in a plane is possible. It will not change the magnitude or it will not change the direction. So I will move the vector. See here, same vector, no change in direction, no change in magnitude, but the vector has reached here. How I have moved that one? I have moved in such a way that the tail of vector B meets the tail of vector A. Okay, so here, see here that this is the head of vector A, and there I am meeting that vector B. Once again, I will explain. The vector was here. I want to add vector A and vector B. For that, what I have to do? I am free. I am able to shift the vector anywhere on this plane without changing its magnitude and direction. So I am shifting vector B. Where I am shifting vector B? In such a way that the tail of vector B meets the head of vector A. See here, I have moved it. So nothing has happened to vector B. Still it is vector B only. Now, in order to find, this is actually graphical method. Analytical method we will learn afterwards. Okay. So in order to find the resultant, it says triangular law. So I have to make a triangle here. How can I make a triangle here? See, this is O and this is B. For vector B, this is C and this is, or this is initial point is P, final point is Q. So what I have placed, the tail of vector B, that is P, head of vector A, that is A. I have made them both same. So I can write just like this. Okay, A and P both are same now. I have made it same. Now, how can I get the resultant? How can I get the resultant? I have to make a triangle. How can I make the triangle from this one? Just I have to join O and Q. If I join O and Q, what I will get? This will be my resultant. R is equal to vector A plus vector B. So once again, I will repeat the process. Pay attention. What vector triangular law of vector addition says? If two vectors are represented both in magnitude and direction by two sides of a triangle. See here, if we are taking vector A and vector B as two sides of the triangle, then the resultant is nothing but one vector which represents the summation. The resultant is represented both in magnitude and direction by the third side of the triangle taken. So here you can see this is the third side. Actually, you have applied this concept long before. For example, as I told earlier, I have walked 4 meter here and I have walked 2 meter here. What is the displacement? Displacement is the shortest distance between initial and final. So this is the resultant one. So you will use, since it's a what type of triangle? Right angle triangle, you will use Pythagoras theorem. That's all. Then you will get the resultant R. Pooja,
Yes, sir.
can you just conclude this triangular law of vector addition? I want to add two vectors, vector A and vector B. First, what I have to look?
Sir, we have to, whenever it's making an angle.
They have to make some angle. That means they are not collinear. If they are not collinear, which law I have to apply?
Triangular law of vector addition.
Triangular law. Okay, good. Vismay.
Sir,
Now, how can I apply triangular law? For example, I have two vectors, vector A and vector B. I want to add these two vectors.
sir, we can change the position.
We can shift. We will say that we will shift the vector. Which vector you will change?
Vector B.
Okay, vector B. How will you change? Where will you place? Where you have to place?
Sir, we will place it such that it makes an angle with a vector A.
Can place it in any case if it makes an angle. So, for example, I can place it here, then it makes an angle, but I am not placing it. What is the condition? The tail of vector B should meet. The tail of vector B should meet. Are you there? Yeah. Tail of vector B. Where should be tail of vector B? It should be at the head of vector A. Clear?
Yes, sir.
We will shift in that way. Okay, so we have shifted. What is the next case? Next thing. Can we get the
Join.
resultant? Hmm. Tell me, continue with me. Don't hesitate.
Sir, then join.
Or make a triangle. The third side. These are two sides
Yes.
of triangle. The third side will give you the resultant R. Resultant R. This is nothing but vector A plus vector B. So resultant is in this direction. What is the magnitude? Vector A and vector B. Clear, Vismay?
Yes, sir.
Now, my question is it always necessary to shift vector B? Can I change vector A? Yes, it is possible. You will get the same value. So for that, what I have to do? I have to shift vector A in such a way that the tail of vector A meets the head of vector B. So I can shift it there, here. So this is vector A. See here, tail and head are meeting each other. Now, how to get the resultant? See here, vector B here, vector A here, two sides. Complete the triangle here. Complete the triangle you will get. How to complete the triangle? Always while completing the triangle, from the tail of first vector to the head of second vector you have to draw. Okay, don't give the direction like this. This is wrong. In this case, let me see. That is very important. How to get the direction? I have shifted it in this way that first vector and second vector. Now, how to draw the resultant vector? I can complete in this direction as well as in this direction. Which one I have to take? In that case, the tail of first vector here. Oh, sorry. The tail of first vector is here. Where is the head of second vector? Here. From the tail of first vector to the head of second vector, you have to draw the line. That will be the resultant. So this is the direction. This is wrong. Varsha. Varsha. Varsha.
Yes, sir.
Is the concept clear?
Yes, sir.
Okay, fine. So now let's move to the other law, parallelogram law of vector addition. In triangular law, what we are doing? Keeping the tail on the head. So here we'll change it. Here I have vector A and I have vector B. I want to add vector A and vector B. Instead of keeping the tail on head, here in this case, I will keep tail and tail together. Now it says that parallelogram. So I have to complete the parallelogram. You know what is parallelogram? Opposite sides are equal and parallel. Okay. So if I complete the parallelogram like this and like this, then how to get the resultant? Resultant is easy. This is the resultant. Diagonal gives the resultant. See here, if you are using triangular law also, where you will keep? You will keep B here, then the resultant is same. So any law you can use. In both case, you will get the same answer. So how can you state parallelogram law of vector addition? Take two vectors A and B. If they are not collinear, place the tail of one vector on the tail of other vector. Complete the parallelogram. Then the diagonal gives the resultant. Diagonal gives the resultant. Karthik? Karthik?
Yes, sir.
Any doubt regarding triangular law or parallelogram law?
No, sir.
Clear? Yes. Okay. So that is about here. Now properties of vector addition. I will say, okay, you can switch off the mic. There are three properties mainly we'll say. That is commutative, and then associative, then distributive. Tell me one by one. Agash. 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 Absent. Febin. Febin.
Sir.
What will be commutative law? Just now I have explained actually this.
So
Commutative.
addition.
Have you heard the word commutative before? Or
So I
first time?
can't remember.
Have you heard the word commutative? That also you don't remember. In sixth class you have learned in maths. Seventh class also you have learned, and most probably eighth class also. When you are studying about whole numbers, then integers, we'll say that the addition of whole numbers is commutative. What is the meaning? You can say that in that case 2 plus 3 is equal to 3 plus 2. Both are same. Okay. So either you can add 3 to 2 or you can add 2 to 3. In either case, you will get the same answer. How can we extend this idea to vector, Febin? We have two vectors, vector A and vector B.
Vector A plus vector B equals vector B plus
A
vector
plus
A.
vector B is equal to vector B plus vector A. This is what just now we have seen. Either you can take A, then bring B, that is A plus B, or you can keep B there and bring A. In both cases, you will get the same resultant. Vector A plus vector B, sorry, vector A plus vector B is equal to vector B plus vector A. Okay, next, Devika.
Yes, sir.
What will be associative property?
A plus B plus C is equal to A plus B plus C.
That is the associative property. In this case, you have to add vector. Okay, so vector A plus vector B plus vector C is equal to vector A plus vector B plus vector C. What is the meaning of this, Devika? Can you tell me? What is the meaning of this statement? I have three vectors, vector A and vector B and vector C. I want to add these three vectors.
Sir, the sum of three vectors does not depend on which pairs are
Order.
added.
Okay, the order is not important. That means either first you can add vector A and vector B, then you will get a resultant. That resultant you add with C. So you will get the net value. Clear? Or what is the other method? First you add B and C. Then you will get some resultant D. That resultant you would add with A. Then you will get the net value. So you can follow any method. If three vectors are given or four vectors are given, first you can add any two vectors and you will get a resultant. That resultant you add with the third vector, you will get the net resultant. That is the meaning of associative property. Okay, now who wants to try distributive property? Last chance for today. Distributive property. Nobody? Actually, distributive property is not for two vectors. It is only for scalar, multiplication by a real number. For example, I will take a real number lambda. Lambda into A plus B can be written as. Now, anyone? Rifa? Rifa.
Yes, sir.
Distributive.
Lambda into vector A plus lambda into vector B.
Lambda into vector A plus lambda into vector B. See here, lambda is the chocolate here. There are two students A and B. I'm telling you to distribute. How will you distribute? You will get lambda one chocolate to A and then chocolate to B. Lambda into A plus lambda into B. So that is about properties of vector addition. Rifa, everything is clear?
Yes, sir.
So last thing we will discuss subtraction of vectors. Subtraction, we can use triangular law and we can use parallelogram law. Okay, but only one thing is that instead of suppose A minus B, I want to subtract B from A. This I can write as A plus minus B. A plus minus B. So this we are going to apply. See here, now subtraction I have converted into addition. A plus minus B. Now, can anyone state how to do? Ashwini, can you give a try? Can you give a try? I told A minus B. Actually, what I want to do? I want to do A vector A minus vector B. Instead of that, what I can do? Vector A plus minus B. Here we have seen what is vector A plus vector B. Also, we have seen what is minus of B, negative of a vector. Ashwini, any idea? No problem. If you don't know, you just say no. This is a discussion. And if you know everything, what is the meaning in taking class? Right? Ashwini, any idea?
No, sir.
Okay, no problem. Anybody wants to try? Anybody wants to try? Okay, then let me only tell here. I have vector A and I have vector B. In this case, I want to do the subtraction. I want to subtract the vectors. So instead of that, I can add the negative of vector B. Okay. So first what I will do, I will place vector A triangular law there. So this is vector B. Okay. Anyone? Kartika, can you tell me what is minus B? What is the meaning of minus B? Negative of a vector. Kartika.
Yes, sir.
What is the negative of a vector? What is the meaning? Negative of vector. We have seen. Its magnitude is same, direction is opposite. Clear, Kartika? Clear? Same direction, opposite
Yes,
direction.
sir.
Okay. So here I want to take, I have B, but I don't want B. I want minus B. So what I have to do? I have to take the same magnitude but opposite direction. So here you see, this is what? This is minus B. Now can anyone try? You got A and you got minus B. How to get the resultant? Arsha.
Yes, sir.
Now how to get the resultant? Triangular law of vector addition. A plus minus B. How?
We have to join third side.
Okay, third side where? I can join two ways. One is here, another one is here. Which one will give me the A plus minus B? From where to where I have to go? From the tail of A to head of B, or from the tail of A to the head of minus B?
Head of minus B.
So here you have to draw. This will be what? This will be A plus minus B, or it is simply A minus B. So actually subtraction is nothing but the process of addition. Instead of adding B, you are adding minus B. Or instead of subtracting B, what you are doing? You are adding minus B. Is it clear, Arsha?
Yes, sir.
Okay. So we have studied what and all we have studied. Just relate. First we have seen what is vector and different examples for vector quantities, physical quantities. And then what else? Then we have seen how to represent a vector. We have seen that it is represented by a letter and an arrow above that. And then what else next? We have seen, what else we have seen? Different types of vectors. Equal vectors, like vectors, collinear vectors, coplanar vectors, most importantly, unit vectors. And then we move to different operations on vectors. What are the different types of operations we have seen? First, multiplication by a real number, not vector multiplication. Multiplication by a real number we have seen. In that case, it is very easy. You have to multiply the vector by magnitude. Okay, the whatever value is given, that number you have to multiply by the magnitudes each case. Okay, then we have seen addition of vectors or subtraction of vectors. Both I will say it together. So how to add or subtract a vector? To add or subtract a vector, you have to use, if they are collinear, very easy. Add the magnitude, give the same direction. If they are not collinear, if they are non-collinear vectors, or if they are making some angle to each other, then you have to add two laws. One is triangular law of vector addition, another one is parallelogram law of vector addition. In both cases, you will get the same resultant. Whichever is easy for you, that you can use.